Pollution is a serious problem for our economy. It's also a good example of a market failure. Pollution is a problem that we shouldn't expect markets on their own to solve. In this presentation, I'm going to talk about that market failure. I'm going to talk about why the amount of pollution will almost certainly be too high in the absence of government intervention. And the big idea is this: the pollution a firm creates is a cost to the rest of society, not to the firm. A competitive firm won't have an incentive to take that pollution into account when it makes decisions. To think about the consequences of this big idea, we're going to use an example of a firm that generates electricity. In the process, it releases a pollutant, sulfur dioxide. This graph shows the different amounts of sulfur dioxide pollution the power plant might release and the marginal social costs of that pollution on the y-axis. In class, we talked about why the marginal social cost might rise as the amount of pollution per week rises. It might behave this way because the number of people affected by the pollution rises faster than the pollution itself. We've talked about the people the pollution affects. Now let's talk about the firm that generates the electricity and releases the sulfur dioxide. In the long run, they need to choose a production technology. They need to decide what kind of plant they're going to build to produce electricity. And we're going to imagine that they have these options: A, B, C, D, E, F, and G. 7 different possible plants they could build. And these plants release different quantities of pollution. Plant A is exceptionally clean and releases no sulfur dioxide at all. Plant G is exceedingly dirty and releases 6 tons of sulfur dioxide per week. Now we come to something a little tricky. What are these social benefits associated with pollution? The basic idea is this: clean production technologies are generally very expensive, whereas dirty ones are generally quite cheap. We say there's a social benefit to pollution because by tolerating some pollution, we avoid the cost of eliminating it. Here's an example. Think about technology D. The table says that the marginal social benefit of using technology D is $600 a week. Why is that? It's because when we choose technology D rather than technology C, we're tolerating 1 additional ton of sulfur dioxide per week. And in the process, we're saving $600 a week because the additional cost of technology C relative to technology D is $600 a week. To understand this better, let's look at a graph of these last 2 columns. Here's our graph. Up here in the left-hand corner, we've got technology A, which is super clean, emitting 0 tons of sulfur dioxide per week. And here we have technology D, emitting 3 tons of sulfur dioxide per week and generating $600 a week in social benefits. And finally, here's technology G, which is super dirty and super cheap. It leads to the emission of 6 tons of sulfur dioxide per week. Let's think for a minute about laissez-faire. If the firm is not regulated, which of these technologies is it going to choose? Well, if it's in a competitive market and it's maximizing profits, it's going to choose G, because G is the cheapest and the cost of the pollution is an external cost that doesn't affect the firm. Let's think about the logic of that choice from society's point of view by including not just the marginal social benefits, but also the marginal social costs. The graph tells us that the marginal social benefit of technology G is 0, and it also tells us that the marginal social cost is quite high, $600 a week. Since the marginal social cost exceeds the marginal social benefit, from society's point of view, it would make sense to pick a cleaner technology. What about technology F? Well, it's definitely better. By getting rid of this ton of sulfur dioxide emissions, we've gotten rid of some very damaging sulfur dioxide that creates a lot of cost for society. We've moved from here to here. But notice the red line's still above the blue line, and so marginal social costs still exceed marginal social benefit. What about technology E? By choosing E rather than F, we've reduced our emissions from 5 to 4 tons a week, and we've gotten rid of some expensive emissions that were costing us $500 in social costs a week. In fact, E is the optimal level of pollution. We can see that by thinking about the movement from D to E. The additional benefit for choosing E rather than D, the savings on pollution control costs, is equal to the additional expense due to more costs from asthma and other pollution consequences. E is the technology for which the marginal social benefit is equal to the marginal social cost. E gives us the optimal level of pollution, 4 tons of sulfur dioxide per week.